But we're really excited here today. I think you saw a lot of announcements from Thomas yesterday, as well as from Sachin. We're just going to go into a bit more details on what's happening in cloud networking. It's very interesting times. I'm super excited to be here. Let me just introduce the panel. We are very lucky to have Anna Berenberg, who's actually a Google fellow, and she gets involved in a lot of cloud networking capabilities. She's going to talk about things that we're doing on the AI ML front, as well as give you some thought leadership on where the industry is headed. Along with that, I also have one of our customers, the largest bank in Canada, Scotia Bank. Payam is going to be joining me on stage during the presentation. I'm really excited to have him here. As brief introductions for myself, my name is Muninder Sambi. I'm part of the cloud networking team here. You'll see a lot of engineering, product management, and the rest of the team that supports us. We will be here after the session as well. If you have questions that we can't take, happy to engage after the session as well. I'll also be joined by Mark Church and my team, who's actually going to show you the power of Gemini Assist. And I'm sure you've all seen it in Thomas's keynote. Let me first start with a recap of what we had announced last year. We announced Cross-Cloud Network, which is super, super exciting. And thanks to many of you who have actually adopted one of the use cases for Cross-Cloud Network. Basically, what it does is you can connect any cloud, any service, any user to any service in a simple, reliable, secure manner. We have over 5,000 customers who have actually adopted one of the use cases. So let's give a big round of applause for the customers who are co-developing with us. Thank you. We really appreciate it. We are going to make history here. We're going to redefine what cloud networking means. Now, let me just start with a quick recap of what Cross-Cloud Network was. It's an open platform that has built-in security, because we fundamentally believe security has to be built in, not bolted on. That's ML-powered so that we can keep up with the adversaries that you're seeing. We also have the Cross-Cloud Network that's optimized for application experience, given the Google backbone network that it runs on. We launched 3 use cases, the first one being around distributed workloads, distributed clouds, distributed applications, however you want to call it. We know for a fact that many of you are on this multi-cloud journey, and we don't want to shape the journey for you. We want to help accelerate the journey, the path that you are on to the cloud. Second, there's a lot of web applications out there that are internet-facing. How can you provide the optimal experience for your users, for your customers, in a secure manner at global scale? And lastly, how do you extend the power of cloud to the enterprise, to the user, to your employees? That's where the hybrid workforce comes into play. Now, all of this is backed and built upon Google's most powerful planet-scale backbone network that we have. Almost 5 times the size of the internet is what we actually have internally that we offer to our customers today. I do want to talk about some inflection points. I'm sure you've heard the theme around AI at Google Next. A lot of our customers are actually looking at Gen AI to fundamentally transform their enterprise applications. We got some really good data from IDC, where 80% of the respondents actually responded to say that they'll be consuming Gen AI in the next 3 years, out of which 66% will actually deploy multi-cloud, even if multi-cloud was not their strategy. We see an explosion and exponential growth in managed SaaS services, consuming SaaS applications more and more, whether they're customer build, Google offered, or even third party. In that 80% of the multi-cloud customers who've done, almost 55% are going to be choosing a new cloud because of the best-of-breed managed applications that they want. Let's not forget the security concerns. I'm sure each one of you is worried about network security and security in general. We did a poll with our customers where we found almost 4.45 million is spent per security breach in an enterprise. And 60,000 attacks were seen on an average per enterprise in 23 alone. We cannot ignore the fact that how we are evolving our applications using AI ML, adversaries, nation-state attacks are using the same technology to keep up, increase the threat landscape, increase the ability for them to actually use AI/ML technology to infiltrate not only your network, the cloud, and data. And we're going to talk about what we can do to help you secure. It's a new era in cloud networking. We are really excited here. Today's session is going to be focused on 3 main pillars. The first one being about modernizing your enterprise with Gen AI. We're going to start with the Google Cloud Assist demo by Mark, and then Anna is going to walk us through some of the networking innovations that are needed to enable and make it easy for you in that journey. Second, we're going to talk about how we can simplify your network, allow you to connect from any cloud, on-prem included, to any service that is available. And lastly, we're going to talk about how we cannot do this alone. We have to do this with an open ecosystem that will enable our customers to not just use the value of cloud, but also bring in the best-of-breed capabilities that they're already using. With this, I would like to now invite Mark Church on stage to come and show us the awesome demo on Gemini Google Assist. Thank you, Mark.
Thanks, Muninder. And hi, everybody. So let's say that you're troubleshooting your network and your uptime is on the line. You've got lots of signals coming in and you don't know where to look or how to focus. So I want to hear from the audience, what is your go-to tool? What is the tool that you reach for first when troubleshooting? NS Lookup. Okay, so DNS team always takes the heat, apparently. By the end of the demo, I hope the DNS team will be vindicated. So over the past 25 years, most technology professionals reached for Google Search as a broad tool to find the information that you needed. And in just the last couple of years, a new capability that we all know very well by now, large language models, have come out, and they have really changed our relationship with information. But we've already seen the space evolve so much, and language models have evolved and matured into fully featured assistants and agents. And so I want to show you how Gemini Cloud Assist will evolve the way that you do networking. As Gemini Cloud Assist is much more than a raw language model. It will revolutionize the entire cloud lifecycle, from designing your network to operating and troubleshooting your network to securing and optimizing your network. And this is because it has access to your context and can reason about your project and your environment. It knows your config, your logs, your metrics, and it's all secured through the IAM credentials of the user using Gemini Cloud Assist. And the fact that it's grounded on Google Cloud domain knowledge makes it even more powerful. So how about a demo? Okay, so the situation is this. So it is Friday afternoon, and you're an application developer, and you get pinged from one of your team members to say that latency has inexplicably increased. It is Friday afternoon, and I don't know how to reach the networking team right now. I know how to troubleshoot my app, but I might not be an expert in troubleshooting networking. However, I do hear that Gemini Cloud Assist can automate the troubleshooting process, so let's give it a try. So what we're doing here is we're going to ask Gemini, can you troubleshoot the symbol shop service latency for me? And let's see what happens. So Gemini has already found something, and it looks here that the latency is correlated with QPS. That's interesting, okay. It looks at traffic is roughly evenly distributed across backends. I know it's a little fast. And it looks like the latency was significantly higher in the symbol EU2 backend. And so Gemini is surmising that perhaps this is a capacity issue, and it gives us a couple things to go investigate. So let's look under the hood to see what happened behind the scenes. In this case, Gemini is using a playbook-based approach for troubleshooting. It has many playbooks, and it's using the language model to determine exactly what playbooks I should execute based on the problem at hand. And then it uses the output of these playbooks, or the insights, to then come to a conclusion about what might be happening. And so this is a very powerful approach. It helps you reduce your search space, and then reduce other things that might not be the issue, and it will reduce the time of outages, make root causing easier, and then also shift the entire troubleshooting process left. So let's continue We always want to trust but verify in these kinds of cases, but Gemini gives us the tools to do this as well. And so what we're going to do is we're going to ask Gemini, show me the P95 latency of the service broken down by backends. Let's use it to check its own work. And so here we can see that the latency actually is a lot higher for the EU2 backend. And so that's interesting. It verifies the kind of insights that we already got from Gemini. Now we're going to do another query. We're going to ask it to show us the load balancer requests per second, again, broken down by backends. And what's happening under the hood here is it's taking our natural language queries, it's converting them to PromQL, and then executing them automatically. And this makes it easy for a non-expert like me to really assess and understand what's going on in my environment, and we're really troubleshooting, or we're really pushing a lot of these capabilities left, which is very powerful for an organization. So finally, let's take a deeper look to see what's going on, and let's actually investigate capacity, and let's see, maybe there's a quota issue here or something like that. So let's ask Gemini to see if there's any quota or capacity issues in this region, and indeed, right away, it's identified a quota exhaustion event in our Cloud Ops logs. Quotas may be misconfigured, I'm not sure, but it's then providing us a link to say if you want to go reconfigure your quotas, here you can go. And so this is already providing us a lot of hints where Gemini is using its playbook-based approach to narrow down the issue and maybe execute several playbooks related to quota exhaustion and all the different ways that it could detect that. And so this is very helpful for us. So let's recap. What did we accomplish here? We identified some relevant trends and patterns that were relevant for the original query that we had. We validated that Gemini Cloud Assist, we validated its work with raw data, which was very useful to know. And then finally, we found a very, very specific error that gave us the needle in the haystack that we are looking for. And so fundamentally, Gemini did not jump to the root cause for us. It led us through this troubleshooting journey and helped us focus our attention. And so it gave us the power of focus. And we're very early in the Gemini Cloud Assist journey, and we can already see a lot of promise. So just imagine what this power of focus can do when designing your network, or optimizing your network, or securing your network, or auditing your network. It becomes a very powerful general purpose tool. And so next, I'll pass it over to Anna, who will take us even deeper. Thank you, everybody.
Thank you, Mark. Well, last year, I spent as a TL tech lead for Gemini Cloud Assist. And for the last 10 years, I've been working as a tech lead for the service networking. And having this dual role allowed me, oh, I forgot the clicker. There you go. Allowed me to uniquely identify right away the gaps we are having with the traffic management in delivering GenAI application. So curiously enough, the industry is talking about GPU, DPUs, and when they're talking about networking, they talk about big pipes. But nobody talks about traffic management. And so today, I walk you through the problem we are solving with traffic management for GenAI applications, and also we'll look at how networking products will evolve in the era of GenAI. Now, Mark just showed you Gemini Cloud Assist in action. And let me show you how it works under the hood. This is a simpler version of Gemini Cloud Assist, much simpler. It's called a RAG application. The RAG stands for Retrieval Augmented Generation, where it's a strategy to help to deal with the out-of-date training data, and as well as control hallucination of LLM. In this case, model has been already trained. So there are three subsystems here. One is data ingestion subsystems that is used to populate the RAG. And to do that, we're using cross-cloud networking to bring secure, reliably, and simply data from on-prem, other cloud, or even the GCP itself. The second subsystem is a quality evaluation subsystem, which is being used to test quality of new models or new model version, given how fast everything is changing. And it compares how response is coming from serving subsystems. And the third one is the one where we're going to spend the most time today, is the serving subsystem. We will be reasoning about request responses going from application users down to GenAI stack and to LLM inference stack. And with that, I'd like to introduce three roles here. One is model creators who use LLM stack. Two, GenAI application developer who owns the GenAI application stack. And then GenAI infrastructure providers. These are the folks who are going to help both model creators and GenAI developers to generalize the stacks and when needed to customize them. The first thing that came to realization is GenAI application is not a web application. And while both have common traffic management goals of optimization for latency and efficiency, they are actually very different. On one hand, there is a small request and response. On the other hand, there is a huge request response due to multimodal traffic that actually cannot be cached. On one hand, there is a deterministic processing time in milliseconds. On the other hand, there is a variable processing time then goes into seconds and sometimes into minutes. On one hand, you can serve the requests and responses in parallel. In another case, it's only one request at a time that occupies 100% of GPU and TPU. And with so many differences, we needed to create a strategy. And so the strategy is one, we're going to develop a GenAI differentiated traffic management. And two, we're going to bring the model into serving networking ecosystem to make it look more like a service. And with that, I'd like to introduce model as a service endpoint. And what does it mean? It actually brings inference stack as a service endpoint, as if it would be another service, which it is. So the model creators own the model, own the inference stack, and they publish the endpoint via private service connect, and the application developers connect to it. And this private service connect is the model that allows us to cleanly separate model creators from application developers. And with that, each of them can add their own load balancer in the space, and these differentiated features can be enabled independently. This solution works, and all the service endpoint will be published in our hub, which is our new product that just went GA, to allow to maintain records of all the services and enable discoverability and reusability. Now, this solution works for all models that Vertex serves. We have 130 plus models, as well as for do-it-yourself models or anything. Now, going back to differentiated features, we actually develop optimized traffic management features for Vertex inside of Google. And now we're introducing this innovation for custom solutions, specifically 3 features here. Per-model routing with client model affinity. This is to help with the multi-turn conversations. Programmability with the service extensions. This is, for example, you can add your own block list, and load balancing based on custom metrics. Now let's dive deeper into the custom metrics. We developed a framework in open source which called Open Request Cost Aggregation, and short ORCA, that allows to return custom metrics as a value in response headers, avoiding the monitoring systems in a loop. And this metric influences traffic routing and backend scaling. So for LLMs, the custom metric that makes sense is actually use queue depth. And let's watch now how we minimize the longest response time while load balancing on queue depth metrics. Well, we usually use a rate for web applications, but it doesn't work that well for Gen AI applications, and so we will simulate how it looks here. So we are sending four requests to the four backends, and you can see that because of variable processing time, the queue on the backend is filling up. And they're filling up in a way that 95th percentile latency is rising up, thus creating bad experience for the customer. So we added custom metric, and now we can fill in a queue depth here, the custom metric, and the target value. And to solve, and it's gonna retry now. Send again the same thing. No, now only we are not round robin. We are sending based on a queue depth. And you can see how P95 is lowering down. And it creates more even natural experience. Now, based on the fact that we having model as a service endpoint, actually the new features for traffic management for everything became available also as traffic management for Gen AI. Three things here: the model health, we're monitoring model health, and we're aggregating the individual health of the models into the into the service endpoint health. And because GKE and Vertex actually are regional deployments, we're providing now cross-regional failover. And so if your model or the stack in one region doesn't work well, then based on the health, using our global footprint, we can just roll over to another region. Traffic splitting, again, it's interesting to make sure we can send traffic to the different models and model version to control rollouts or evaluation. Now, the new thing that came is actually long-form context. You heard yesterday Thomas talking about Gemini 1.5 Pro with a 1 million tokens context window. What does it mean? It means 1 hour of video, 11 hours of audio, and huge lines of code and words. Imagine the request size this size, right? What are you going to do with that? And what kind of latency you're going to experience? So we're introducing streaming for Gen AI inference, and specifically load balancing for streaming. So instead of using RPS or utilization, we're going to load balance based on number of streams, and within each stream, it's a bytes in and or bytes out, depending on which direction you can load balance. And this arrives later this year. Now we just looked at how we are solving traffic management problem for Gen AI application right now, and now we're going to look ahead at how networking will evolve for generative AI. Now, we believe that networking products will become AI-assisted products. With one, every product will have natural language support. It's not just a chat, it's this multimodal support. Imagine that you are bringing a network diagram, PDF of network diagram, passing it in, and off comes out Terraform, filled with a subnetwork, firewall rules, routes, load balancers, etc. How many days and weeks do you think you save here? Second, intent-based configuration. How many people here don't hear before about intent-based configuration? Probably everybody heard, but it never appeared. But now it's a time, and the reason for that is because it's very hard to translate from natural language down to the knobs. You need something in between at that level of intent. So you can translate from natural language to intent down to the knobs. Now, what if intent-based configuration is not good enough? What if application developer comes and asks, I want to create an application that serves under 100 milliseconds and costs no more than $100 a day? Well, no intent-based configuration will help here. We have to go to load balancing and traffic routing guys and ask them to actually work across the whole stack of microservices to optimize end-to-end. And the same thing for autoscaling. We have to go to autoscaling and ask not to only autoscale based on a compute demand, but also on a budget across the whole stack. Now, we also believe that we will evolve to support all these 3 roles that I spoke about before. For the model creators, we continue as a networking to work on the big pipes for training, RAG, and fine-tuning. And we're also going to be working on new caching techniques. Imagine now you cannot actually cache because every response is being created for each of you individually. For Gen AI infrastructure providers, this is an area I believe is going to grow very big because we'll need to customize the stack as it grows. And we're going to create open SaaS ecosystems for Google customers and providers, not only to be able to plug these little SaaS services with extensions, but also have full lifecycle management so they know the GCP is the right place to bring their AI products here. And for Gen AI developers, today, if you look at Gen AI developer code, it's actually filled in with routing. Can you imagine? It's not your typical networking routing, but it is a huge distributed system. And so every time you have to decide where are you going to forward or route, or what is the decision making to send to another hop. Now, the same way as routing evolved from L3 to L7 to the API management within the routing, I believe long-term this is going to evolve to push down from application code down into networking. And we probably will come out with something like AI routers. We are in infancy of building Gen AI applications. A lot is unknown, but what is clear is that networking will have to adapt in all areas. And I'm excited about what the future of networking for Gen AI holds. And to close it off, I will leave you with a beautiful poem Gemini composed for me when I prompted it with networking for Gen AI. Enjoy it, and thank you. Back to you, Muninder.
Wow, that is amazing. Thank you, Anna. Thank you, Mark. Let's give them a round of applause. You know, while I was listening to Anna and Mark talk about AI and some of the innovations and challenges ahead from a networking perspective to solve and make AI ML workloads much simpler from a networking perspective, I thought about one thing. You know, the saying goes, what happens in Vegas stays in Vegas. But in this particular case, I actually think what happens today in this particular session is going to redefine cloud networking across the globe. So I'm really excited. Coming back to where the session is, as a student of cloud, one of the things I really like about bringing new innovations is you'll be amazed on how the pace of innovation is happening, especially in cloud. How applications are changing, how you want to be able to consume best-of-breed cloud services in a very secure manner. And that's not easy when it's done across a huge base of our customers and the breadth of the open ecosystem that we have. So let me talk about how we're going to actually simplify some of the challenges that you see today. We all know for a fact when you're trying to deploy services in a multi-cloud world, it's extremely complex because of the bespoke nature that it is there. It's extremely hard to get security right. It's fragmented, inconsistent, and you will have multiple point product network securities in order to be able to either be compliant or you protect your infrastructure. And the complexity quadruples because now you have to work across 3 different teams. The operational complexity of working between DevOps, NetOps, and SecOps just to bring up a service does not take days. It takes months, if not years. Harnessing the power and the innovation speed that you expect from a cloud. We are really pleased of what Google Cloud can offer to help simplify and make it easy for you to deploy any cloud to any service in a simple, reliable, and secure manner. With this, we are introducing Service-centric cross-cloud network, that allows you to now connect to any workload that you have, whether it's for AI/ML workloads, Vertex, or any best-of-breed GCP services, from on-prem assets or from any other cloud, in a simple, easy, secure manner, and fully reliable, fully managed by Google Cloud. In this particular model, services get published by DevOps. Workloads are then extended to access these services and secured along the way. Security cannot be an afterthought. In order to do this, obviously, you need multiple products. There are many products that you see that are listed, from Private Service Connect to NCC to Web Secure Proxy to our load balancer innovations. And obviously, we are now announcing the general availability of Cloud NGFW to protect against zero-day threat protection. Now let me go into a bit more details on how service-centric cross-cloud network can help all the three different admin personas and accelerate the pace of innovation. Starting with the concept of a services landing VPC that offers independent swim lanes across all the personas. DevOps use PSC to publish the service. NetOps uses a simplified hub-and-spoke topology to be able to provide PSC propagation. SecOps comes into the landing VPC and applies consistent security posture between workloads and services. This particular architecture now offers 20 times better threat efficacy that is uniform across any workload that is trying to access any service within Google Cloud, while making it compliant from a data protection perspective. And obviously, now that you can accelerate your journey into the cloud, there's also a TCO saving of up to 40% because you don't have to build bespoke networks. And you might have heard of the term service networking from many people, from many vendors out there. The biggest challenge with service networking today, it is bespoke, it is custom built, whether you're connecting to a cloud-native service or a customer service or a partner service. And that approach simply cannot work if you want to be able to accelerate the pace of innovation. I'm going to go into a bit more details on exactly what we are introducing. So at the bottom, you see there's Google Cloud workloads. There are other cloud service workloads. There's on-prem workloads that are now trying to connect to either GCP services, could be BigQuery, Cloud SQL, Vertex AI, and others. Third-party services, MongoDB, Confluent, Databricks, et cetera, or could be your own service. We are going to provide a consistent way for you to be able to connect to all of these in a simple and secure manner. Think of this as one network with PSC everywhere that's optimized and makes it simple for DevOps to publish using traffic management for canary rollouts or A/B testing, being able to provide cross-region failover with health checks, NetOps getting the ability to use NCC with a hub-and-spoke topology, being able to dynamic route propagation, being able to propagate the PSC connectivity, endpoint connectivity, and SecOps coming in to deploy Cloud NGFW firewall for the best threat efficacy, being able to do zero-trust workload security with Z and MTLS, at the same time being able to protect your data as you move petabytes and zettabytes of data into the cloud. Many of these things are in preview. I would definitely encourage all of you to give it a view, give us feedback, so that we can continuously co-develop and improve customer problems. At the same time, security cannot be an afterthought. And today, many of you have come and talked to us about how you have implemented fragmented security in order to be compliant. And that approach in the cloud, in cross-cloud network architecture cannot simply work. You want to protect against zero-day threats, against zero-day posture. You want to be able to protect your data. You want to be able to provide the same level of security for managed or unmanaged endpoints that users might be using. We built an entire portfolio of network security. We took a step back and said, if we have to solve this at an architecture and a platform level, we have to rethink how network security should be deployed. And we categorized them into three parts: securing the workload, securing your data, and securing your user. Securing the workload starts with zero trust identity access management policies between workloads and managed SaaS. It starts with zero-day protection for threat. It starts with the ability for you to protect your internet-facing applications with ML-powered innovations in Cloud Armor. On securing the data, we have Cloud DLP that you can secure your storage buckets and be able to ensure there's no PI information that is out there. How do you extend that same capability for data in transit to make it a complete DLP solution? So we'll show you how we integrate with Cloud DLP as well as with third-party vendors that you might be using. And securing the user is something that we launched. We have given you the choice of the best-of-breed SASE vendors that you can bring in for your hybrid workforce, along with the SD-WAN or non-SD-WAN vendors that you want in order to bring your traffic into the cloud and use the GCP backbone as your enterprise WAN. Let me give you a few examples on securing the workload. In this particular case, I have 3 workloads. They're in different clouds. With a simple click and a simple policy construct, you can now define which workloads can access which particular service. And in this particular case, a workload X that's in different cloud, could be an on-prem, is not allowed to access a customer-managed service, which is SQL-based, with a simple click of a button. And we can apply these IAM policies that you would have applied for users in a very similar construct, extended to the workload and services construct as well. Securing the workload, you cannot do that if you do not have a firewall. We fundamentally took a firewall and made sure, first, we provide you the best efficacy that's there in the industry, 20 times better than any other that is out there in the marketplace. Second, we made it simple and secure. We provide high-performance TLS decryption in our infrastructure itself, not having to slow down the firewall by itself. And best of all, many of you have actually struggled to integrate a firewall on-prem as well as in the cloud. We made it very simple, where you do not have to worry about making any routing change to integrate a firewall into a path, whether it's with BSE or it's VM to VM or any other application path that you're trying to protect. We also introduced the notion of network security posture control, where we can apply org-level policies, IAM provision tags, and layered incident response. On securing the data, like I talked about, the most important thing is you are securing your data at rest. You want to be able to extend the same capability that you're using onto the network for data in transit. And you're going to use service extensions in order to be able to integrate with third-party as well as Google native Cloud DLP solution. Now with this, I'm going to invite Payam from Scotia Bank to come here on stage and talk us about his journey, his organization's journey into the cloud and how cross-cloud network can help. Thank you, Payam.
Hello, everyone. So I'm going to start this section with a quick introduction of Scotia Bank, and mainly for the folks in the room who are not familiar with Scotia Bank, but at the same time, for everyone to appreciate the scale and the complexity of the environment that we have within our organization. So Scotia Bank is one of the largest banks in Canada with a strong presence across the Americas. We operate in more than 20 countries. We serve clients across Canada, US, Pacific Alliance countries, Brazil, Asia-Pac, and Europe, and we have more than 88,000 employees. So as you see, I think now you can appreciate, because of the diversity and diversified portfolio that we have and the scale of the organization, we have multiple global data centers, and at the same time, we leverage multiple public cloud. So now I'm going to talk about the cloud networking complexity in an enterprise when you use on-premises backbone network services for providing the connectivity. So in this example, in this slide, the blue box is enterprise backbone on-premises, which provide connectivity to start with an on-premise data center workload and a third-party enterprise vendor, which are out of your organization in enterprise. With the introduction of the public cloud, let's call it in here, the on-premises backbone need to provide connectivity between internal services, external services, and a public cloud. But as soon as you add the alternate public cloud, you need to keep providing and expanding your investment on-premises infrastructure. And to add more, when you have multi-cloud hybrid application, now you rely on on-premises to provide connectivity and capability for your modernized app in a public cloud to function, which is a concern from my perspective and any architect. And as you go forward in any global enterprise, as you add more data center and more third-party services, you can see how complex this enterprise will become. And please note, I haven't even started talking about securing this connection. There are so many connectivity, and if you add security, it's very hard, and you need to really rely hard on your architecture and engineering team to maintain this. Any failure in your on-premises infrastructure could impact your modernized applications. So now I'm going to go quickly to see how we solved this problem in Scotia Bank with the help of Muninder and our account team in the past 12 months. So in here, we're looking at the blue box in a GCP fabric. We use GCP fabric as our enterprise network backbone, and we provide connectivity as any other organization to cross-interconnect to on-premises for workload and a GC-hosted workload. What we have interest in Scotia Bank, we have a services landing point, which internally we call it NCC. Sorry, internally we call it CNC because NCC was taken. So we call it Central Network Connectivity Service. So with doing this, we have, of course, we provide shared services native to GCP to all on-premises or even cloud services. So far is all classic. And we use CCI now for connectivity between our GCP, our primary public cloud, and alternate public cloud. The benefit of this architecture is, first of all, you can control the latency because where you have the region, you can look at and enable that capability between the public cloud. And more importantly, from an architecture perspective, you're not relying anymore on on-premises infrastructure to support cloud-to-cloud connectivity. I don't think anyone in the room believes that we should leverage legacy way of a network service for providing connectivity between cloud and cloud. As you go forward, we leverage the same capability, the same pattern, the same architecture for connectivity to our third-party services hosted in GCP. Because as you imagine, the benefit of having these services in GCP is we can rely on a capability of the service-centric cross-cloud network capability that the team is introducing for leveraging the services directly between our different services, our services hosted on-prem or in the cloud to a third party hosted in GCP. We don't need to wait for a carrier to run a circuit for us. We can enable it as we go forward. And as you go forward, you can extend that to your partner managed services for service to service when you have your credit card partners or any other partner to do that connectivity. Again, these are predictive architecture. You know how to connect them. You can put our customers and our services in that connectivity method that we discussed. And as you go forward, you can take the same approach to use the PSC for connecting between enterprise shared platforms that leverages multiple projects in your GCP or on-prem. As you see, there will be, I don't know how many more use cases, but you can fit any use case that you have to connect to this environment. And I just want to add that because of this architecture, this is a predictive architecture. Now I can tell you how to secure it. So with insertion of the cloud NGFW, you can protect the services. You have different categories. You can define different security profile based on the trust level that you have with your organization. And you can apply different services, so DLP policies, and modify those. And with additional benefit and adds-on that come with the cloud NGFW. So to sum up, our architecture, our transformation to the new service-based networking architecture leveraging service-centric cross-cloud network is heavily rely on a PSC. We rely on the layer 4 to layer 7 proxy that we introduced in the organization. At the same time, we are leveraging CCI to make sure that our cloud-to-cloud functionality is not reliant to any other on-premises services. So with that, I'll pass the stage to Muninder, and I hope you enjoy this session.
Thank you, Payam. It's always good to see a customer actually talk about our innovations and how they're going to be using it. We're super excited to be working with you. Obviously, on the network security side, coming back, how do we secure the user? This is something that we launched. You can use SD-WAN in your branches, your campuses. You can have traditional IPsec. You can terminate the traffic within Google Cloud and pick your choice of best of breed, SASE or firewall vendors. Last year, we announced Palo Alto Networks, as well as Broadcom with Symantec as our key technology partners. Today, we are pleased to announce we are also extending that to Zscaler. So from a Magic Quadrant perspective, majority of the SASE vendors that you would have chosen from your best of breed now work. And we work with all SD-WAN vendors, all routing edge providers as well. At the same time, Anna talked about our ability to actually do service extensions. And we did talk about this in our last session. We are pleased to announce that service extension callouts is now going generally available on our load balancers. It's already in preview for Media CDN and will be available in the cloud service mesh later this year. What is service extension? Just as a recap, it's an open programmable data plane that allows you to insert third-party SaaS applications in any part of the pipeline for your application flow. What kind of capabilities would you need this for? It could include inspecting or blocking requests, header transformations, DLP, as well as backend routing, and many more. It's a very powerful, flexible, open ecosystem where you can bring your best-of-breed SaaS capabilities and seamlessly integrate them into the architecture, into your workloads, into your application flow. I do want to give an example of Apigee. There's a lot of customers who actually reached out to us on the challenge that they have with shadow APIs that expose data logic and infrastructure to malicious attacks. And in order to be able to protect against these shadow APIs, customers have to deploy API gateways at multiple places, which becomes really hard from an operational perspective. With service extension now, customers can easily find shadow APIs using Apigee API security and not have to deploy API gateways at every place that is required for them to protect. A really powerful innovation. There's a lot more. I'm really excited about this one. We are going to onboard a lot more ecosystem partners to ensure that we can bring the best-of-breed SaaS capabilities to help you protect, help you do advanced technologies that were not possible before. Now, we cannot do this alone. We have to work with an open ecosystem. So I'm just going to walk through what that open ecosystem is. You all heard about PSC today, one network with PSC everywhere. Obviously, there's a lot of GCP, Google Cloud, native services that are available. But we also have a lot of third-party ecosystem vendors who are actually part of this ecosystem. Within the last year, we've seen like 236% growth in services. And we'll keep adding to this. We expect our catalog of PSC services to be north of 500, if not 1,000 services by the end of, in the next 12 to 18 months. At the same time, the cross-cloud network ecosystem is growing. On the service extension side, we've got Datadog, Imperva, Broadcom, Palo Alto Networks, Qt. These are all applications and capabilities that you need in your application flow, and you want to be able to seamlessly integrate it. You can do that with service extensions. We're extending on the observability front with Dynatrace, AppNeta, Catchpoint, and others. On the security side, I already talked about it. We have a very broad portfolio. On the networking side, we're also pleased that we're working with Infoblox, especially from providing an IPAM service for your enterprise. And you'll see many of these new innovations, new blogs, new use cases show up in the next 3 to 4 months with our ecosystem partners. In summary, cross-cloud network is the new way to cloud, a new era of cloud networking. You heard about the AI ML inflection point that we have. That's going to fundamentally require us with a new stack, new capabilities that can be delivered in a simple, consistent, reliable, and secure manner. It's the one network that we want to be able to develop that actually accelerates application deployment by enabling DevOps, working with SecOps and NetOps. Secure the network, secure the workload, secure the data, secure the user. With cross-cloud network, you can achieve up to 40% reduction in TCO, 35% lower latency, and the best of breed network security with 20 times better threat efficacy than any other solution out there.